Hello and welcome to today's video on the atom. So we're going to be talking about the atom. But I think before we talk about the atom, it is really important to talk about something that I think confuses students so much from the difference between Key Stage 3 and GCSE or GCSE and A-level. And that is this term that I absolutely hate, particle. The term particle causes so much confusion with A-level, and I promise you, no matter what stage of A-level you are at, this is an important bit to watch because it holds people back so much. And whenever I explain this concept to them, it just makes things so much easier because there are so many things at A-level that require you to talk about specific particles, and because of the way that you're taught at GCSE, you're so confused about that. So, if we talk about particle, the first thing that will probably come to your mind is the very first model of the particle that you ever drew. Key Stage 3, solids have particles like this, liquids have particles like that, and gases have particles like this that are nice and spaced apart. You probably remember drawing this model. The problem with this model is that we're referring to these things here as particles, but these particles are made up of particles, e.g. water. That's a particle. So these particles here are particles, but those particles are also made up of oxygen and hydrogen, which are particles. And then my oxygen is made up of protons, which are particles, neutrons, which are particles, and electrons, which are particles. And then my protons and neutrons are made up of things called quarks. A proton is made up of two up and a down quark, which are particles. So we've got this huge disconnect here between what's going on. And the size difference between these things as well is colossal. An oxygen atom is 10 times smaller than a water atom. My protons are about 10 million times smaller than a water atom. And then my quarks are 10 trillion times smaller than a water particle. So the things we're referring to are widely different sizes. And so referring to them all as particles gets confusing, especially when we get to A-level and we start to talk about the forces that hold the solid, liquid, and gas together, because we talk about these things called intermolecular forces. You might have heard about them. They're to do with these particles, holding these particles together. But they're specifically to do with these particles, not these particles, not these particles, or not these particles. So if you're still stuck in the GCSE mindset of calling all of these small things particles, when you get to learning intermolecular forces, your brain gets really, really confused and you'll start talking about things about electrons disconnecting from things or bonds breaking because you fundamentally don't understand the difference between particles. So, I do not want to use the word particle for any of the videos that I do on my chemistry course. I think particle is a horrible word. It's like germ, referring to like bacteria, viruses, and fungi. They're wildly different. No biologist would refer to these things as germs, but for general society, it's a term that fits. I'll just end with one final thing about why you shouldn't use the word particles. If we look at salt, a grain of salt, that is a particle of salt. So you can't really even say that particles are just small things, because a grain of salt, you can see it with your eyes. It's massive. So don't use the word particle. Instead, we're going to use the specific words that particles have, and only those words, because it will make understanding the differences between these particles and the different natures of chemistry so much easier. Okay? So, the first type of particle that we're going to break apart and never call a particle again is an atom. Now, atoms are individual building blocks. Every single thing that you see is made up of atoms. And all these atoms share characteristics with one another. We're going to go through these characteristics of the atom first. So we're going to draw a model of the atom. We're going to pick apart all the parts of the atom. And then we're going to tell you some facts about the atom. So, as with a lot of things in chemistry, there is no easy starting point because you have to accept a bunch of things that you can't see with your eyes in real life. So I'm just going to launch into it and you're going to copy it down, and then that is going to help you to understand it. So I'm going to draw this model of the atom that you've probably seen before. You're going to draw 4 circles and a bigger circle around the outside. Now, kind of looks like a bowling ball maybe for someone with massive fingers. This is my model of my atom. I'm I'm going to talk about all the constituent parts of this atom now. So first off, in the middle of my atom here, you're going to put two little pluses. This here, this little circle with a plus, is referred to as a proton. Now these things are three-dimensional, it's just we're not drawing in three-dimensional, so it's important that you don't do what I just did and say circle. They are spheres. That does sometimes crop up in exams and trip people up when they, like, I've seen a multiple choice question before that was like, what shape is a proton? One of the options is circle, one of the options is sphere, and people always tick circle. They're obviously just trying to trip you up, but it's just an important thing to think about. They are 3D. Anyway, what is a proton? Well, it's a particle. So immediately you can see the problem with the term particle. The atom's a particle, but it's got particles in the particle. Don't use particle. So a proton is just a single bit of mass. And we simplified the maths in chemistry quite a lot using a number called Avogadro's number. Avogadro's number is amazing because it simplifies all the numbers in chemistry so that we can say that the mass of this is 1, instead of referring to its actual mass, which is, I think, 1.67 times 10 to the minus 11 kilograms off the top of my head. Bit of an annoying number, so instead we simplify it to be 1, much easier. Protons also have a charge of +1. What is a charge? Because we don't really get many charges in your day-to-day life. One thing that you will be aware of is a magnet, which obviously has a north and a south pole. You know that north poles will repel other north poles, but they will attract south poles. You can imagine plus and minus charges as the same thing. Plus charges will attract negative charges and repel other positive charges. Electromagnetism is one thing in science, so it basically is kind of the similar effect. That's my proton. Let's get down to this circle that I haven't drawn a plus in. This is called a neutron. Like Jimmy Neutron. This also has a mass of 1, and it has no charge. It's neutral. So these are kind of just, they're there to kind of just space out the atom a little bit. They're just a particle that exists. You just have to accept it. Neutrons. So that is a neutron. I shouldn't say a particle. There are hadron that exists. These are both types of hadron. Don't need to know that. Okay, so collectively, these things lumped together are called the nucleus. Just like you have in a cell in biology. It's just that thing in the middle of the atom. On the outside of this, we have this ring. And in this ring, you will sometimes see these little circles drawn. Sometimes, sometimes not. These circles are electrons. Electrons are negatively charged, so the opposite of a proton, and they have no mass. They actually do have a mass. It's 9.11 times 10 to the minus 31 kilograms, but that mass is so much smaller than the mass of the nucleus that it effectively doesn't matter. And so for the case of chemistry, you're just going to pretend that it has no mass because it has no relevance. The mass doesn't affect anything. When we get to like higher level physics, maybe at like PhD level, then the mass is going to start to affect things, but for your level, it doesn't. So we're just going to say that they have no mass. So these are the three constituents. Now, people often get confused between these constituents, so it's important to commit these to memory. It's easy to remember the charges because protons begin with a P, just like the word positive. So protons are positive, and neutrons have the word neut in them for neutral. So those two are easy to remember. People sometimes forget the charge of an electron. If you struggle to remember the charge of an electron, just do the other two first. Protons must be positive, neutrons must be neutral. The only other charge that exists is negative, therefore electrons must be negative. That's fine. You don't have to immediately memorize something. If you can get to the solution, that's much more useful than just memorizing and rote learning. Finding processes for getting information from information you already have is the key to getting high grades in exams, because it means you don't need to know everything. You can know half the stuff, and if you know how to get information from that stuff, then you know everything without needing to know everything. Does that make sense? Remembering the masses is a simple thing of just remembering that the bits in the middle have mass and the bits on the outside don't. Now, you might get confused about which things go in the middle and which things go on the outside. I've got no easy way to memorize that. You've just got to commit it to memory. You've just got to keep doing it. Keep drawing the models of the atom and keep reminding yourself that electrons go on the outside. It's something that if you do not remember this when you're in A-level, you're kind of screwed. So you should definitely commit this to memory as quickly as possible. Now, the final thing that I want to talk about atoms today is this term called elements, which you might have heard before. Now, elements kind of refers to the identity of atoms. And we look at my identity of atoms using a periodic table. Now, we distinguish my atoms based on the number of protons they have. Again, this is something you need to commit to memory. This atom that we drew at the start is a helium atom because it has 2 protons. I will go through how you discover this from a periodic table in another video, but the number of protons is the atom. Changing the number of neutrons does not change the element. It does not change the atom. A helium atom with 2 neutrons or a helium atom with 3 neutrons are both still helium. The elemental identity of that atom is helium. Changing the number of electrons will also not change the elemental identity. 1 electron, still helium. 2 electrons, helium. 3 electrons, helium. But if I was to squeeze another proton in there, suddenly this becomes lithium. So the identity of my atom is based entirely on the number of protons. Now, there is some stuff in this video that is not immediately understandable. You just have to commit it to memory. Chemistry is a complicated subject because it deals with things that you can't see in real life. And so the only way to be good at chemistry is to find these fundamentals, commit them to memory, and then use them as a springboard for the remaining ideas. If you do not commit the atom and things like the atom to memory when you start A-level, you are going to really struggle for the rest of the year. But if the only work that you put in is these fundamentals at the beginning, then A-level will be an absolute breeze.